Okay, Math 3, welcome to lesson 6.3. Here's page 2. You can see page 2 is starting off with a polynomial function, and they're asking me to evaluate with an input or x value of -1. There's of course two ways to do that. I could just take -1 and put it in for x. So if I do that, I would have -1 to the 6th, which is 1, minus, that'll be 1, so that would be 0, minus 1 plus 1, so it's 0. I know the answer, 0, just by plugging it in. But just to review, you could also, of course, use synthetic substitution. So doing synthetic substitution, right? 1x to the 6th, 0x to the 5th, -1x to the 4th, 0x cubed, -1x squared, 0x 1. So I'm doing it this way because we're going to probably end up using this later on when we're working with these polynomials. So hopefully this will refresh your memory. So bring that down. -1 times -1 is 1. -1 times -1 is 1. And -1 times 1 is -1. And sure enough, we get our same answer, 0. All right, next question. Find all the roots. Oh, well, here we go. Here's where we're going to need to use that synthetic division in this case to find my roots, unless it factors. Oh, it does actually factor, doesn't it? So I would go ahead whenever possible and factor this. So I'm going to factor by grouping. So look at my first group. I can factor out a x squared term. Right, so I'm going to have, or sorry, not x squared, x to the 4th. Okay, and my second group, I'm going to factor out a -1. And I can see my factor by grouping worked out nicely. Okay, oh, and we're finding roots, right? So that means equals 0. Okay, I got a difference of squares here. I got a difference of squares there. And I have yet another difference of squares here. That's a sum of squares. A lot of students try to factor that. That's prime. Okay, so we could kind of clean that up if we want. It's x squared plus 1. There's a factor. Then I, of course, have a double root and another double root. Okay, so you can see my roots are -1 with the multiplicity of 2, +1 with the multiplicity of 2, and then I have 2 complex conjugate roots, which we may as well find those, right? Okay, so my roots are positive -I, -1 with the multiplicity of 2, and +1 with the multiplicity of 2. Okay. Again, if you forgot how to factor this, you could have just started going through your P's and Q's, right? And you can see our only choices were positive and -1, and you could have started dividing out using synthetic division are factors of +1, are factors of -1, until eventually you got to the same spot. Okay, next problem type. We're moving on to rational functions. Remember, with rational functions, we have issues of asymptotes and or holes. Looking at this guy, I can see that x is not allowed to be 0, either here or here, because then I would have 0 in the denominator. So I know my domain for this, x can't be 0. Okay. Always good to point that out before working with any rational functions. Okay, this question is asking me to evaluate for an input value of 4. Notice if it had set an input value of 0, I wouldn't be able to do it. But 4 is allowed. So just go ahead and plug 4 in there. Okay, so let's see. That is going to give me 1 over 3 times 16, which is 48. 1/48 minus 1/4. Getting a common denominator, that's 1/48 minus 12/48. So that's going to give me -11 over 48. Okay, on to letter B. This time, instead of giving me an input, they're saying, when will this function equal this expression? Or, yeah. So this expression, also being rational, has an issue with domain. And again, x cannot be 0 in that. So they both have the same restriction on the domains. So set them equal to each other. Okay, so at this point, there's different ways to proceed. I'm going to go ahead and multiply the entire equation by the least common denominator, which will take care of my denominators. So I'm going to multiply this whole thing by a 6x squared over 1. So my first expression, 6x squared divided by 3x squared, well, that's just 2. 6x squared divided by x, that's going to give me 6x. And over here, I'm just going to have 1. Subtract 2. And I get x equals 1/6. Now remember, whenever you finish solving one of these, you got to go back and make sure that it is a valid number in the domain. So in this case, 0, right, on any part of this would have been unacceptable, but I didn't get 0. I got 1/6. So 1/6 is fine. Go ahead and plug it back in to check. I'm not going to do that check at this point. It'll be fine. It'll work out, but go ahead and do that on your own if you wish. Okay, moving on. Our next problem type, we've got a square root function. And in this case, we want to know, when will the function be equal to 3? So that's an output or a y coordinate. So simply say 3 equals the square root of x minus 1. Again, square root functions have a restriction on their domain, right? In this case, my domain would be that x has to be greater than or equal to 1 to get a real output. All right, solving this, we would square both sides. And we would find that x equals 10, and 10 is acceptable in my domain. Okay, moving on. Now we're going to take and set this equation or expression equal to this expression. We have a new domain restriction on this guy, right? 3x minus 14 has to be greater than or equal to 0. So x has to be greater than or equal to 14/3. thirds, right? And of course, 14 thirds exceeds 1. So this is the domain when I get done. If I get any value that's less than 14 thirds, it's an unacceptable solution. All right, so let's go ahead and do it. So at this point, we will square both sides of our equation. Subtract x, add 14. So I'm going to have 13 equals 2x. So x is going to equal 13 over 2, or in other words, 6.5. Then I go back and I say, well, is 6.5 acceptable? And yes, it is, right? 6.5. This over here is 4 2/3, right? 6.5 is larger than 4 2/3. So that's an acceptable solution. Feel free to check it back in the original problem if you wish. Okay, moving on. Our next problem is dealing with a cube root function. And this time they're giving me an input of 43, so just put 43 into the cube root function. All right, 5 times 43, that is 215, plus 1 is 216. Okay, the cube root of 216 is, of course, 6. So this is 2 times 6 minus 2, which is equal to 10. Okay, so with an input of 43, my output for this function would be 10. You can think of it graphically, x coordinate, y coordinate, if you were to graph that. All right, next, this time I have an output or a y coordinate of 10, and we're trying to find the input or x coordinate. So 10 equals that cube root expression. Okay, start by adding 2. Now I will divide by 2. And now I need to cube both sides. Subtract 1. And lastly, divide by 5. And not surprising, I got 43. I already knew that from the first problem. With an input of 43, I got an output of 10. Then they're saying, oh, at an output of 10, what's my input? Well, 43, of course. Okay, but that's the work that you would do to solve the problem. All right, moving on. We've now got exponential functions. So the question is, for what value of x will I get an output of 81? So say 81 is equal to 3 to the power x minus 1. Now, remember, when I can make the bases the same, it's an easy approach. If I can't make the bases the same, that's when I have to take the log of both sides. Well, I know that 81 is actually 3 to the 4th power, so I'm going to do that. 3 to the 4th power is equal to 3 to the x minus 1 power. Now that my bases are the same, the only way that these two expressions can be equivalent is if their exponents are the same. So I know that this exponent over here has got to equal 4. Okay, so x is going to have to be 5. Okay, moving on. This time, we're asking when will the output be 82? 2. Well, I know it's going to be just past 5, right? Just a little bit more than 5, but it's not going to be a nice clean number. So this is the problem where I will have to use logs to get an answer. So I cannot make the bases both base 3, so I'm going to take the log of both sides. Okay. I can bring that x minus 1 now down and make it a coefficient. At this point, I can either distribute the log of 3 or I can divide by log of 3. I think most of my students like to just divide by log of 3. So that'll give me log of 82 divided by log of 3 equals x minus 1, and then just add 1. So x is going to be equal to log of 82 divided by the log of 3 plus 1. And if you want to get a decimal for that, put it in your calculator, and of course it's going to be just a little bit bigger than 5. All right, on to the next problem. This problem didn't print properly. This is supposed to be a log equation. It's supposed to be 1/3 log base 2 of x and then a plus 5. So that's what that was supposed to say. All right, so there's my log equation. When will it have an output of 7? So 7 equals 1/3 log base 2 of x and then plus 5. So step 1, subtract 5. Okay, now multiply by 3. And we'll have 6 equals log base 2 of x. And now hopefully you guys remember, at this point, there's no log on the left-hand side, but there is a log on the right-hand side. So to solve this, we're just going to convert forms from log form to exponential form. Our base is 2, our exponent or power is 6, and it will equal x. So 2 to the 6th equals x. And 2 to the 6th is, of course, 64. Okay, so there's my answer. Okay, on to the last problem for this page. We're going to stick with that same log equation and say, when will it equal 10? Subtracting 5. Multiplying by 3. And converting forms. So 2 to the 15th equals x. If you want, jam that in the calculator. I'm just going to leave it as 2 to the 15th. So there we go. Okay, I'm going to stop the video there. That's page 2, and then I'll pick up a new video for page 3.